term or the y term to cancel out, because now you want to subtract equation 1 from equation 2, or you want to add equation 1 to equation 2, but you want to make sure that doing that will help you eliminate one of these terms so that you can have only a problem of x or a problem of y. Then when you get any of them, you can put them back into the equation and look for what the corresponding value of x or y will be. Looking at this 12x and looking at this 6x, I believe it's easier for me to convert 6x to 12x so that I can say, well, this equation minus this equation. Look at this 5y and this is minus 2y. If I wanted to leave my x guys alone, I could deal with this by making sure I convert them to almost the same kind of coefficient. If I multiply 5 by minus 2 and I multiply minus 2 by 5, they're going to both give me minus 10y, and I can say, yes, this minus that. It's up to me now, isn't it? I prefer to deal with the x. So, equation 1. So it's always good to label your equations so you know how to refer to them. Equation 1 and equation 2. I'm just going to say something. Multiply equation 2 by 2. Now the reason I'm multiplying equation 2 by 2 is so that this 6x can become 12x. But you cannot just multiply this one without multiplying the entire left hand side and the right hand side so as to keep the equation balanced. So we now have a problem that looks like this. Oh, I think I need to get a new sheet. Alright, so we now have a problem because this is what we have. So we now have a problem that becomes the first equation, 12x plus 5y equals to 7, equation 1 still. Equation 2 now becomes 6x minus 2y equals 10, all multiplied by 2. 2 into bracket 6x minus 2y equals to 2 into bracket 10. And that becomes, the problem now becomes 12x plus 5y equals to 7, equation 1, and 12x minus 4y, because I'm now opening this bracket up, equals to 20, equation 2. It is so easy for me now to say equation 1 minus equation 2, and that gives me something, because if I subtract this from this, they are going to cancel. So 12x plus 5y minus 12x minus 4y is 12x minus 12x, 0. 5y minus 4y, okay, 5y minus 4y equals to 7 minus 20, because all of this minus all of this. And that gives you 9y equals to minus 13. By now, I believe you understand what to do when you've got a small value minus a big value. Okay, so y becomes a formula minus 13 over 9. Well, we can leave the answer this way. Sorry about all the troubles I've caused you. I mean, but if you want to convert this to a mixed fraction, of course you can, but I don't think anyone is going to be really bothered at this point, because you've done the bits of the work that you know that's really an issue. Now you've got what the y value is. So we're looking for x now, right? Because we're told to solve for x and y. So how do we get x? Go back to your equation. We had equation 1 that looks like this. Remember, equation 1 says 12x plus 5y is equal to 7. That means that if you know what y is, which is minus 13 over 9 equals to 7. So by substituting back into the equation for y, we can make x the subject of the formula. So it becomes 12x minus 13 times 5 is 65, isn't it? Over 9 is equal to 7. Now make x the subject, so that we're going to do quietly. I'm not going to say a word. That's 12x